Okay, on to our next talk, which is called Get Your Head in the Clouds by Sean Verity. Sean, take it away.
Good afternoon. Can everybody hear me?
Yep, we sure
Okay.
can.
A little rusty with the Zoom here and there, but okay, very good. Thank you. So, hey, everybody. Hope you're having a great B-Sides Austin. My name is Sean Verity. I'm a tester at Black Hills Information Security. And I want to talk to you about some of the fun things I've been discovering lately about applying cloud pen testing, TTPs to app testing, whether that's web testing, mobile app testing, or even a little bit of desktop or thick client testing. So with that, let's get started. There we go. Okay, so topics to discuss. I want to talk about why I think it's interesting. We're going to talk about using Selenium, which is a quality assurance tool to automate your testing. We'll talk about a couple of different technologies in AWS to include Cognito. I'll touch a little bit on the instance metadata service and how that comes into play with any cloud pen testing TTPs or any sort of app testing that's hosted in the cloud. We'll look at AppStream a little bit. It's a pretty interesting technology I'd never heard of until about 6 months ago, but it's pretty cool if you get to play with it. Also touch on a little Azure scenario that turned out to be pretty interesting during a recent pen test. And the last section will be kind of a couple things to look into. It won't be necessarily any concrete TTPs, but it's certainly like a couple of things I'm thinking about, are there potential attack vectors? And we'll talk about that as we get to that section of the presentation. So why is this interesting? Well, first and foremost, personally, I think pivoting is a lot of fun, no matter what shape it's in, shape or form, whether it's pivoting within an Active Directory environment from one host to another, or if you're pivoting from a web app into like the underlying operating system, or pivoting into whatever that environment is. When you're moving from one environment to another, I just find that really interesting. Another reason that I think it's interesting is there's a decent chance that the app that you're testing was recently migrated to the cloud, Azure AWS. As a result, some of those defensive controls, the traditional ones that we have been testing against for years, they might not be as robust as the on-prem iteration of that app was. So the first topic I want to touch on is fighting automation with automation. Basically, when talking about fighting automation, so some of we'll use this use case of reCAPTCHA. So a couple of the reCAPTCHA flavors are essentially solving JavaScript challenges, which is a problem if you're using something like Burp Intruder, because Intruder doesn't have functionality to solve a JavaScript challenge for you and include that in the request. Another good use case for using automation to fight automation is if you encounter Amazon Cognito for authentication in something that you're testing, one of the default protocols that it uses is Secure Remote Password Protocol, SRP, which is really complicated. We'll see that in just a second here. So the first use case, reCAPTCHA, like I said, it relies on solving JavaScript, and that's how it figures out if you're launching automated attacks or not. It's kind of nice, like these two particular flavors of reCAPTCHA, because it's pure JavaScript, it runs in the background, it's minimal impact for the users, much better than having to click all the traffic lights or boats that you see on the highway type thing. The problem is, as a tester though, it breaks typical intruder attacks, as I alluded to earlier. So the workaround that I've used before is to automate the browser. We'll jump to the next use case. So Amazon Cognito, it's basically an identity provider service that Amazon AWS provides. And you could see this during a web app. You could see this during a mobile app test. I've seen it during it was a mobile app test that had a web app for the administration of that mobile app service. Yes, driving on. So as I said earlier, Cognito uses this protocol called Secure Remote Password Protocol. If you look at the picture on the right, that is a screenshot from Stanford University's website. I did a little bit of cursory research on the history of this protocol, and it looks like it might have started at Stanford. But the takeaway is, if you look at it, that's a breakdown of how SRP works. And the key distinction or takeaway is the password is not transmitted across the wire. So if Burp can't see the password, you can't mark the password payload in your intruder attacks, which is a problem if you're trying to do brute forcing. You can see some of those parameters there, SRP and whatnot. As far as testing and looking for clues that you're running into SRP in your burp logs, you're going to see parameters that start with the name SRP. You know, to be honest, this protocol kind of reminds me of TLS. It looks like there's like a session key generated, and that's how the client and server authenticate each other without sending the password across the wire. I'm not an SRP expert though, but that's my very quick analysis of this protocol. So again, back to why are we talking about this? This is a really hard thing this would be very difficult, if not impossible, to implement in the burp. It goes back to my theme of let's automate the browser for stuff like this. So if you look at the picture on the left, that is a screenshot of a login form that I made for a demo app. We'll do a demo in just a minute here. And then the screenshots on the right inside of that bubble is a couple of screenshots from Burp. That's what the request looks like when it goes across the wire. You see it, it's really complicated. You got the SRP, it's this huge hexadecimal thing. And then in a subsequent request, there's a password claim secret block. Looks like a, you know, encrypted something. There's a signature, so there might have to be like a signature matching. Looks like a lot of coding and math. That's not my strong suit, so that's kind of what prompted me to look for an easier way forward with testing something like this. And that's where Selenium IDE comes into the picture. So it's really easy getting started with Selenium IDE. It's a browser plugin. I think it's available for pretty much every major browser. I know Chrome or Firefox, I've used it on that. I think I've even used it on the Microsoft version of Chrome Edge. I've used it in there. Works just fine. It's usually pretty easy to get up and running with it. You don't have to dig too far into it. Another nice benefit of using Selenium IDE for some of your test cases is you can save your attacks and reuse them. So that's good if you're, you know, you test something and then you're asked to retest that thing like 1, 2, or even 3 months down the road. You could start with your Selenium script to kind of refresh your memory and bootstrap how you need to retest the thing because you probably forgot after 3 months. So I want to touch a little bit on some strategies when you're using Selenium to automate some of your testing. The first thing that you want to try is just try recording with Selenium. There's a button or an icon in Selenium. It looks like a record button. Go to your app, click the record button, do the thing, log in, whatever it is that you're testing, and that usually works. Interestingly enough, it did not work when I was putting together the demo for this talk. I had to dig a little bit through the DOM and, you know, basically tell Selenium where to look for the elements that I wanted to mess around with and update and whatnot. So that would be your second or backup strategy. You would essentially start with dev tools in your web browser, mock it up with JavaScript, and then just copy the JavaScript over into Selenium. Selenium is pretty easy to get the JavaScript running in there so you can automate it. All right, and with that, we're going to see a real basic demo. This is really just going to log into that app. This app that I made for the demo is just a simple node.js demo app. It logs in if you submit the correct password, and it's using Amazon Incognito on the back end. And I think it's in this demo. It might be the next demo, but you can kind of see how complicated the thing looks underneath the hood when you're looking at a login request with Burp. That being said, let's go ahead and get this started. All right, so here's the logging in, and you can see all the requests going by with Burp there. That's manually logging in. You wouldn't want to do a brute force attack where you're guessing like hundreds or thousands of passwords or whatever you're doing, or a password spray for that matter. So this is just kind of looking at the inputs and outputs just during a login request. It's, if you ever done any sort of web app testing, this is obviously much more complicated than most web apps. Now we're going to take a look at that login, automating it with Selenium, and basically a quick walkthrough here. So we've got 5 steps or 5 commands. First one just opens the login page, and then you see these little snippets of JavaScript here, 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 and here. So the first one basically selects the username field, and then it writes the username. The next one selects the password field and writes the password. And the last one, there's a JavaScript event that needs to be triggered in order to kickstart the SRP process. And the final step is clicking the sign in button. But we'll see what that looks like when you run it with Selenium. So there it is. It's nothing too crazy at this point. Again, just to give you an idea, I don't know if you're like me, but I like seeing things get automated. I just have fun watching the browser do things without me clicking anything. I just find that fascinating. But all right, so that's a basic Selenium login there. So where you'd want to use this more practically speaking is if you're doing web app testing. Like, one of the things that you're probably going to have to test is brute forcing. Does the app have protections against brute forcing? So you can do that with Selenium. Essentially, you would start with building that basic login script, and then you can do loops inside of Selenium. And the boxes that are here on the right kind of show what that would look like in Selenium. Basically, you would create an array of all your passwords right here. And then the next step, you'd define your loop. And so password list would be the name of that loop. And then password would be your iterator. I put in here the pause command. That's something that can come in useful if you're running your Selenium scripts and you're seeing that they're failing for some reason. Try putting a pause statement in there, for 1 second, 2 seconds. I got 3-second pauses. It's in milliseconds. That's why it says 3000. But put some pauses in places where it looks like your script is breaking down. And a lot of times that's enough to get you through whatever it is you're trying to automate. And then finally, you got to close the loop. Okay, so this next demo will be a brute force demo. Here we see that same JavaScript code. There's an array of passwords. We defined our loop here. There's a pause statement there. I got another pause statement towards the end. I found that was necessary in this case in order to keep Selenium running to do this automated password guessing. Another side note with automating brute forcing attacks is you can easily swap this. You don't have to brute force. You could do a password spray. In that case, you just put like an array of usernames and tweak your script and then put the single password in the password field. With that, let's see a quick demo. There we go. All right, this is just looking at the code inside of Selenium. Password list is the array name, and passwords are iterator. Pause statement, and we run it. So you can kind of see in the upper left-hand corner, if you watch over here, incorrect username or password, which is a good response. It means there is no username enumeration probably. Nice and vague. And then there in the final guess, we see that the password was found. So one thing that's really neat, kind of, this will tie into the next demo. Going back to Amazon Cognito. Cognito is a pretty cool service. If your app talks to Cognito or it's tied into Amazon Cognito, Cognito will give you creds when you authenticate by default. Maybe it's by design. I forget. But yeah, anyways, you get creds, which is really fun. You can kind of see that in the burp screenshots here. So in the request, I've logged in, and then in the response, there's a few names that are highlighted: the access key ID, secret key, and the session token. Well, those values would go into .aws /credentials file. And that credentials file is used by the AWS command line interface to start doing cloud pen testing, essentially. It's really easy to get started with the AWS CLI. If you've got Debian or Ubuntu or Kali, it'd be just an apt install AWS CLI. Yeah, and then so once you get those creds, your next steps are basically going to be to verify, audit, and escalate. Verify is just a nice thing that you want to do occasionally, especially in this case, because if you look here, the session token, that's an indicator that these creds are going to expire at some point. So you can use the AWS STS get caller identity subcommand to figure out if your creds are still good. You know, you do that occasionally, like say you're testing something with the AWS CLI and you find that, wow, why isn't this working anymore? You know, one of the first things you can do is just check, like, are the creds still good? Because they might have expired. So the audit step, there's lots of different tools. There's the one that's in this screenshot, AWS Service Enum. There's Weird AAL, a whole bunch of tools out there. Pacu, Rhino Security Labs, really cool tool. Lots of tools out there to audit AWS. Essentially what these, well, I can tell you what this one basically does. It's automating AWS CLI commands and subcommands to figure out what can these credentials do. And so that's what you do here. And you can kind of see those same names, the access key, secret key, and session token here are just command line parameters to the tool. Then finally, escalate. That's where, say you do your auditing and you find out, oh, okay, I can see, well, these credentials allow me to do fun stuff in IAM, like I can create access keys for other users. That's basically what this screenshot is showing here. We've created an access key for the AWS Cloud Admin, which in this particular case happens to be a highly privileged user within the account. And time for another demo. Here we go. All right, so basically in this demo, we're going to see, picking up from the brute forcing attack, we'll see where you get the AWS access key after you authenticate. And then I skipped the audit step in this demo just because it takes a long time for demo purposes anyways, to do that auditing where it's checking all the things that you have access to. And we skip straight to the escalate in the demo where we generate an access key for the AWS Cloud Admin account or user, excuse me. So here we've got that request. You can see over here, there's the creds. And we're just going to copy all that stuff into a credentials file. And the credentials file would go in your home folder under a .aws directory so that AWS CLI can find it. And so the reason you have to use this file is because you've got the session token. You need the session token for this particular access key because it's a temporary access key. With AWS CLI, you can configure persistent access keys with a configure command. But in this case, because we need a session token, you have to fill out the file or credentials file. And so there's the final step there where we use those credentials and found out that the credentials from here that we got from logging into the web app could be used to generate an access key for an AWS Cloud Admin. Now we can do all sorts of things within this AWS account. All right, a little bit about the instance metadata service. This is definitely like a fundamental concept. Anytime you're doing any testing of anything that's in the cloud. So you'll see the instance metadata service, IMDS, in AWS or Azure. In AWS, there's two versions. You got version 1 and version 2. Version 1 is definitely older than version 2, obviously. It tends to be enabled within AWS environments, though, even to this day. So if you can, see if you can get AWS access keys from the IMDS using the version 1 method, which is just as it looks like on the slide. It's just a simple curl request to that non-routable IP address. So this is an IP address. Obviously, it's non-routable. This is something that needs to get executed on the AWS EC2 instance. So scenarios where you might be able to do this is if you've compromised that EC2 instance, or if you've got a vulnerability that lets you do remote code execution, or maybe there's a server-side request forgery. That could help you get the access keys using version 1 of the IMDS in AWS. So V2 is a little more secure. It's going to make it a lot more challenging to get access keys through like an SSRF. And the reason is because of the things that are highlighted in yellow there. You got to use an unusual method, the put method. You have to send an atypical request header that X AWS EC2 metadata to get a token, and then you have to use that token in a subsequent request, again using another atypical request header, X AWS EC2 metadata token. So usually, like say you're exploiting like an SSRF, a lot of times to read the response, it's as simple as injecting like an iframe, and then which will do a GET request for you just fine. And that can work with IMDS version 1. With IMDS version 2, you can't really do the iframe thing and send a request with those unusual headers. So just something to be aware of if you're trying to get access keys from something that's hosted in AWS. Azure is a little bit different. It almost seems like Microsoft was a little more forward thinking. This actually presented a roadblock for me recently in a test. Uh, I've highlighted there in yellow to get an access token in Azure. You need that atypical header metadata true to go out with your request to get an access token for an Azure instance. I had a situation, a test a couple months ago where had JavaScript execution and like a PDF rendering thing on the server, and it would render JavaScript. And so it did SSRF stuff. And I was injecting iframes, and I put the Azure request to the metadata service, and I got back a response as an error message saying you can't have, you're missing the right request headers. So again, something to be aware of, if you're testing Azure or AWS, even if the attack fails like it did for me a couple months ago, it's still good to see that failure and the response, because then at least like what was it that stopped you, and perhaps you could find a workaround, or at the very least you can tell the customer like, hey, this is what happened. It looks like this prevented the attack, et cetera, et cetera. All right, switching gears to another really interesting technology in AWS called AppStream. I first came across this while testing a desktop app or a thick client. Before we started the project, I thought, okay, cool, we're gonna get the thick client app. I'm gonna, build a VM. I'm gonna build a fuzzing engine, and we're just gonna fuzz this thing, get crazy inputs, and monitor it with one debug and see what happens. And then we did the ROE call and found out this thing's hosted in AWS AppStream. I was like, what is that? I have no idea what AppStream. And so I got to learn what AWS AppStream was through that project and found out this is pretty cool. The long story short, what do you do if you're testing something in AWS AppStream? Hack it like you would a Citrix virtual app. Look for restricted desktop escapes. I've got a link down here, which has like a ton, I don't know, like maybe a couple dozen different methods of escaping a restricted desktop environment. And I think I used this during the test, and it worked really well. So the AWS AppStream architecture, this is a high level view. This is a very basic diagram or architecture of what AWS AppStream could look like. And it's got the flow of how the user gets into using the app that's being streamed. Essentially, they log in. I apologize for the small pictures in the slide here. They log in, which brings them to a portal. And then in that portal here, they get to select the app that's going to be streamed. And after they're authenticated, in the back end, what's going on in AWS, there's the streaming gateway, and there's EC2 hosts, and they all live in a fleet. There's a stack, and it kind of does some access control stuff. Image builder is where the app is built and configured, and all this gets delivered to the user through a web browser. So some key considerations if you're testing something in AppStream is these apps are hosted, and again, on EC2 instance. They're not persistent. So, and they have like a default expiration of 16 hours. So once the session is over, 16 hours is up, whatever progress you've made with hacking the EC2 instance that's underneath that app, it's gone. Maybe you want to do that because there's probably not as good of logging, and if you can compromise this AWS AppStream thing like at will, like it might be a good way to go. If you need to like establish like more persistence, though, I'd recommend making an effort to get outside of that underlying EC2 instance, as soon as possible, because it's going to expire. So some terminology. This is hopefully really helpful for you if you end up testing it or you're working with an AppStream administrator. You'll have at least a basic understanding of what they're talking about. Three big terms here: stacks, touched on it earlier. I think of stacks as access control. It's handled in the stack configuration. of the app that's being streamed. There's different ways that access to the streaming app is handled. The administrator might distribute one-time URLs. They might have some federations set up with third-party service. There's also options to persist data, like using S3. This is also where the copy-paste policies are established for the app. The next one is fleets. Basically, fleets where you think of like VMware VirtualBox. This is where you're managing the hardware settings. How much disk space is this thing going to get? CPUs, Active Directory. This is also something that I found to be really interesting when I was testing something in AppStream. This might be familiar to some of you. I didn't know you could do this, but there was an entire Active Directory environment hosted inside of AWS, and that whole thing supported this AWS AppStream instance. So it actually looks like it's reasonably simple to hook an AWS AppStream instance to an existing AD environment that's in AWS. But just something to be aware of. It's something that could be there. It ties into the earlier point of if you need to persist and you want to persist outside of that EC2 instance, there might be a whole Active Directory environment behind that app that you could compromise and live in. The next term, images, and a couple of terms to go with that. So the term on the right, image builder, this is the tool that the AppStream admin is going to use to build the image that gets streamed. It's basically, think of it like a golden image. Every time the app gets spun up, this is the golden image. It gets saved in the image registry and it gets deployed to the user when they start using that streaming app. So what does an AppStream breakout look like? This is a super basic one using, in this case, I built something to stream Calculator off of a Windows host. So to break out of Calculator, because when you log in, all you would see is Calculator. You could, using this potential method, you could check the help menu, which would open, in this case, Internet Explorer. Then you type the path to cmd.exe, which brings you to the download. Select run it. You're logged in. Who am I? Now you do stuff inside of the EC2 instance. And then remember, this thing's hosted in AWS, and you've got that IMDS service that runs on the EC2 instance. So make sure you take advantage of that and get those AWS access keys while you're in there. Like I said, using version 1, it's just a simple curl request for that URL that you see there in the screenshot. And now for a demo. Okay, so here you see on the left, this is what it would look like for the user. There's the app that's getting streamed through the browser. You also see how do you do like copy paste into and out of here, because we need to copy the access keys into our attacking system so we can do AWS pen testing from the attacking host. Unfortunately, it's not as well. It's probably a good idea. It's not as simple as just copying the strings out of your browser window and pasting it into this text file. There's a kind of an intermediary step, and you'll see that in the demo to copy the credentials over. So here, this will start with a very basic breakout to get a shell on the EC2 system. So just navigating to cmd.exe. Of course, we want to run it. Okay, and then now we're going to get the AWS access keys from the IMDS. Here's a demo of what it looks like to use that copy paste functionality. and just right click it in there. Boom, you've got your access keys. We can start copying all that out. Control V, paste it into your credentials file. And then finally that access token. So here do our SDS get caller identity, and boom, we know that we've got good creds. And you can use those with your favorite AWS cloud auditing tool. All right, switching gears from AWS to Azure. I wanted to build a demo for this based off of something that I saw during a test recently. But after thinking about it and looking at how to build it, it would have been really hard to replicate it. So this is mostly true. The end state, I didn't actually get global admin, but I did get there was an application that was assigned to the administrator that let me pivot and other stuff. But anyways, that would have been really hard to rebuild. So that's why it's faked. The whole thing is fake, but it did happen, but I didn't want to share details about the customer. So anyways, with that being said, the name of this story is my Azure profile was hacked. So I was testing a web app and I came across some clues that this thing was using Azure AD. You know, there are JWTs involved in decoding the JWT. I saw Azure in there, like an Azure group name. Another hint was at the login page, I would type in the username, and as soon as I switched or clicked inside the password field, it boom, it like put a domain name and a backslash before the username. I was like, wow, that looks a lot like Active Directory. So that was another hint. You know, as I was moving forward in the test, I thought about it. Well, the big hint was during the ROE call. I'm pretty sure the customer told me that we moved to Azure recently. So neither here nor there, but so with that being said, I thought this thing's hosted in Azure. I wonder if these accounts would work like in Azure AD. So I messaged another tester at BHIS and I said, hey, if you think you got, you know, credentials for something in Azure AD, how you know, what's the quick check? We'll log into the Azure portal. I was like, oh, okay. So he gave me the URL to the Azure portal. And so I did that and logged in. I was like, okay, cool. I'm in the Azure portal. This is fun. So I saw something really strange though when I was logged into the Azure portal. I was looking at my user profile, like my user profile. I'm not looking at someone else's, like my own. I couldn't edit my user profile, but I saw that my scanner did. Like I saw like a cross-site scripting payload or something for my name inside of Azure AD. I was like, that's weird. Why'd the scanner, you know, get to change my name, but I can't, and I'm logged into Azure AD. So it got me to thinking, you know, I'd scanned the app with admin creds. It is fine as a QA environment. I do not recommend doing that for a production environment for obvious reasons. But there was a feature in the app when you're logged in as an admin that allowed you to update user settings inside the app. So it got me to thinking like, well, if, you know, there's a service account on the back end of this web app, it's got privileges to update my, you know, settings inside of Azure AD. I really wonder if this thing can update other Azure AD accounts. And you can kind of see this is a mocked up request of, you know, what that would look like say changing the password in that web app here, you know, with the initial password change, I've got my username. I'm just nobody special in Azure AD. You know, what if I change that to somebody special in Azure AD? So the next logical step at this point was I need to go spelunking in Azure. Spelunking in Azure is a lot of fun. There's really lots of rabbit holes you can go down. But here's a few areas that I would suggest starting with if you find yourself in this situation. So take a look at the user's profile, look at their group memberships, look at any applications they've been assigned, any assigned roles, and all of that can really be initially accessed through the Azure Active Directory icon over here on the side window. So spelunking in Azure AD, I see my profile and I find this user called somebody special in Azure AD. It's like, oh, this is fun. So I see assigned roles. You know, they're not a member of group or application or anything else, but they've been assigned a role. And then so when you see assigned roles in Azure AD, think to yourself, assigned administrative roles. You can probably do administrative stuff. So in this particular user happens to be the global admin, which is like domain admin in Azure AD essentially. So this is a really good, user to compromise, great admin to compromise. So I jump back to the web app, change the password request. Instead of nobody special, I change the username to somebody special, and you can see a success. So bada bing, bada boom, global admin proves. And that's the end of the Azure story. So finally, I mentioned earlier, there's a couple of items that are really just for your consideration. I consider them occasionally myself. I came across this thing in a web app test called B2C, Azure Business to Consumer. I didn't know what it was at first, but I saw this domain b2clogin.com and a subdomain off of that. I thought, what is this b2clogin.com? So I started Googling it and I found out, oh, it's tied into Azure AD. That's interesting. So, how do you find it? If you got burp running, you're going to see requests go out to a subdomain of b2clogin.com. And that's your clue that there's some authentication that's being outsourced to Azure B2C with the thing that you're testing. Some other clues, you'll see URLs that have B2C_1_ within the URL, so that B2C_1_ gets prepended to the names of user flows that are configured inside of B2C. Some other hints that B2C is in play is you might see Azure, somewhere else in another URL or again within a JWT. So this falls under the something to consider category because you don't get a whole lot of access within the Azure AD portal as a B2C user. I don't think you can even log in to the Azure AD portal as a B2C user by default. But it'd certainly be interesting if somebody found a way to work around that. And there's a vulnerability that allowed a B2C user to, I don't know, get into the Azure AD portal and do stuff. So hopefully somebody finds something cool with that. I'm certainly going to look the next time I run into an app that's using B2C. Next one, AWS S3 buckets as you're doing app testing. So there's a few different ways to find it that's worked for me. The easiest is, and this has become one of my favorite extensions, is JS Miner. JS Miner will find lots of neat stuff buried inside of JavaScript for you. And it'll let you know if it sees hints of AWS S3 buckets. Other things you can do to look for S3 buckets is just search your burp history for aws.amazon.com, see if there's anything there. Or if you're testing something and you don't see either of those clues, maybe you're testing something and you see the app calls out to this URL and you start navigating up to the root of that URL and you see a request that looks similar to that. Well, that's a hint that you've got an S3 bucket in play. And I've highlighted there the name of the S3 bucket in this particular example is test2. So there is a ton out there about hacking in the cloud. So I want to leave you with basically some training ideas, some cloud methodology ideas, and some tools that would probably be useful for you for doing cloud pen testing. In case you come across any cloud pen testing attack vectors while you're doing any sort of app testing, there's some really awesome training the BHIS offers. Bo has a really great breaching the cloud class. To go with that, you've got BB's awesome modern web app testing course. Those two would like go hand in hand really well for this kind of thing to come up with some interesting attack paths. As far as cloud pen test methodology, there's a really nice collection of cheat sheets that Bo has put together and made available for free on GitHub. I'd highly recommend looking at that. And finally, there's a list of a few tools. That first one, Rhino Security Labs, I think they've got several tools there, like the PACU and some other stuff. Weird AAL is another nice one. Cloudy Noom. That final tool that's listed there, Scout Suite. So that's a nice tool for. I had a customer ask like, "Hey, can you tell us if there's any like misconfigurations?" Basically Nessus for like a cloud environment, and I said, "Oh yeah, okay." And so I used the tool Scout Suite, and it would audit and check and presented really nice like dashboards type views and stuff like that, and it would risk rate some potential misconfigurations for the customer to look into. But Scout Suite would be the tool for that kind of thing. That brings me to the end of the talk. There's my Discord handle. So are there any questions at this time?
I don't see any questions in Zoom, but there may be some waiting for you over in Discord on your channel. Attendees,
Okay.
to remind you that Sean has agreed to pop over in Discord and chat with you about this talk for a little while after he's done. So take your questions there, I guess. I can't read any out to you though, Sean. Thanks for the excellent content. I'm sorry, I don't want to take away control from you, but I think we'll take a quick break and transition at the bottom of the hour to our next talk. So we have 11 minutes break, everyone.
Sounds good.
Sean.
Thank you. Thank you, everybody.